Okay, welcome everyone. My name is Matthew Magaldi. I'm a developer at BlackRock. I work on an application for financial advisors. This is my colleague, Vaibhav.
Hello, everyone. My name is Vaibhav, and I'm also a developer at BlackRock, and I work on data science platform.
So for those of you who don't know, BlackRock is the largest asset manager in the world. And our company is heavily invested in building out technology for our Aladdin platform. So Aladdin is BlackRock's core operating system. Facilitates investment managers' connection to data, information, people, and technology. So today, we'll be discussing our open source project, Argo Events, as a case study of how BlackRock is automating our research environments and scaling our data science workflows. So let's begin with a brief history of data science at BlackRock, and Kubernetes. Now, we can't talk about the entire history of data science at BlackRock because we would literally have to recount the entire 30-year history of our firm. The fact is, and we all know Kubernetes hasn't been around for 30 years. The fact is that BlackRock has been investing in and deriving value from data science for the better part of our existence. In fact, we've been successful based on the optimizations that we've applied to financial portfolios and to modeling those financial portfolios' risk. So this background story isn't going to cover all of that. It's going to cover more around how we brought Kubernetes into the picture. Right, so let's begin with why. Why did we want to use Kubernetes for our data science platform? So we're all at KubeCon, so we've attended a lot of the sessions, and there's many reasons to use Kubernetes for data science. But here are some of the reasons that we use Kubernetes. So we wanted a highly available tool set for our researchers, analysts, and scientists to use. We wanted to give them the compute and resources they needed when they needed them. And we wanted them to be able to use the tools they were proficient working with and they were used to working with, all while building on top of a more powerful platform. And most importantly, as a regulated financial firm, we needed to enforce strict isolation between our users and their information to ensure intellectual property and data privacy barriers. So how did we build this platform? We started building the Kubernetes data science platform around 2 years ago. And as we've alluded to, Kubernetes is at the core. Scheduling gives us on-demand resources and compute with little downtime. Containers gives us configurable and isolated environments. We use Docker for our container runtime, Helm's our operational tool for version deployments. We use GitLab for CI/CD and a DevOps platform. And finally, we chose Jupyter Notebooks with internal Python APIs installed for data access. So very simple setup. So since its first deployment, the data science platform has gained traction across many BlackRock teams. So I won't go through all of the uses that I have here, but I'm going to touch on a couple highlights. For example, our scientific active equity teams build ESG or environmental, social, and governance alerts for a fund's positioning. So for those of you who don't know, it's a score from 1 to 10 for a fund based on various criteria and rankings in a environmental, say, owning tobacco stocks or stuff like that. We also have business operation teams building quality control processes for our analytics and to validate them and ensure accuracy and preciseness. And we also have our portfolio modeling team, modeling our complex financial securities and instruments on this platform. So really overall, the platform has been transformative for 3 major reasons. First, it's really augmented the technology available to these investment teams. Secondly, it's increased the collaboration across our technologists to service the investor base. And lastly, it's really challenged the status quo on how we engage our investors and how we deliver on these key business insights. So despite the successes of the platform to date, as developers of the core infrastructure, we've gotten a lot of feedback around how to make it better. And we've heard things like, okay, this is awesome, but I want to build, a real-time solution or something that's automated so I can use the latest data and as soon as it becomes available. Or I just want to automatically kick off this workflow. I don't want to have to do it, manually at the end of each financial quarter. So basically, users wanted to be able to schedule things they were doing in their Jupyter notebooks. They didn't want to have to manually kick off these jobs. They just wanted to be notified when it was all done. So now timing is an easy thing to do. And most platforms support this. And Kubernetes even has their core batch cron jobs. But scheduling is actually really difficult. We needed to think not just about a simple time trigger or a simple cron expression, but we actually needed to take into account a lot of things like file transfers, object CRUD operations, streaming messages, and complex holiday calendars. So you remember how I said time was easy? Well, in finance, it's not. Thanksgiving, for example, is a US holiday, but the LIBOR market, which is basically a market between London banks to exchange funds, that market is still open. So in finance, a concept like accrued interest becomes crucially important. So after we kind of digested all of this feedback, we condensed it down into the problem statement that you see up here. How do we automate the scheduling, manage the exceptions that always arise, and provide transparency into these complex batch processes? Now, this is definitely a lot to consider. And exceeds the scope of even kind of data science of where we started. But really, when we boil it down, essentially our goal was to just make it easy to build and specify workflows that cross-spanned multiple teams and multiple domains. So I just want to clarify for a second what a workflow is. A set of tasks that you can put into separate, isolated parts. Break it down. So, for the first 2 weeks of starting on this project, Vaibhav and I started by researching existing open source platforms that we could leverage as a starting point for kind of the orchestration and composing these workflows. And as of the start of this project, at the beginning of the year, we found a number of existing technologies at our disposal. So I just want to highlight a couple that we found. One of the first ones that we found was a project called Airflow. Now, Airflow is an Apache incubating project, and they define their workflows in Python. And they have a number of pluggable operators that allow a degree of customizations around your workflows. The second project that we found was a project called Brigade. Now, Brigade is developed at Microsoft, and they're part of the Helm ecosystem. And they kind of introduced a terminal-like scripting or pipes for building these containerized tasks on Kubernetes. And lastly, we found a project called Argo. Now, Argo was different because they defined their workflows as custom resources. They were extending the core Kubernetes API to build workflow objects in the Kubernetes API. So I don't want to talk about our whole story of how we came to a decision, but ultimately we decided to pursue Argo for really 3 main reasons. First, it was very powerful. We spent a couple weeks walking through the examples, and we were amazed at what we could do with this. Secondly, it was by far the most Kubernetes native approach of all 3. And lastly, it had an extremely active and engaging community. So during the next couple weeks, we read tons of documentation about building Argo workflows, and we're playing around with the platform, building our own. And we, during one of our many impromptu brainstorming sessions, which we had a lot of, we started by drawing something like you see here up on the board. Very simple, straightforward, linear process. And after a couple hours, we put together all of our thoughts and various use cases, and we ended up with something like this, which was a complete disaster. And we were like laughing about it to each other. We were like, thinking about presenting this to our DevOps team and telling them, hey, can we do this? And yeah, that was a no-go. We needed a better solution. We needed something that could span multiple teams and multiple domains. So we started by, breaking apart this big puzzle. And you could think of it kind of like this complex monolithic workflow, which we termed kind of the Uber workflow, which was like this huge workflow cross-spanning our entire company that would from, early in the morning would generate our analytics, and then at the end of the day, we have a nice report with, all of our ready information for our clients. Now, we separated these components, by natural API boundaries and data layer access, because we knew kind of like different teams wouldn't want to be working on the same workflows with teams that they didn't, really work on the same stuff with. So we ended up kind of with something like this. We had workflows inside of workflows. We had the compositions of workflows. And we really needed something to tie these pieces together, right? So this is kind of my transition into, why we started to develop this eventing platform that we open sourced. And in addition to connecting these pieces together, what's important is that it's come into a map of dependencies. So, you can not just have a linear process, but you have task 1, task 2, and task 3, but you also have task 4, which, task 2 is, dependent on as well as 1. So, you have a map of essentially dependencies at a higher level than just a simple workflow. So, this is really the motivation for our event framework, Argo Events, that we open source to the Argo community and to the entire open source community. And so now I'm going to hand it off to my colleague to introduce the solution.
Thanks, Matt. So yeah, we saw that we need a framework that's pretty much an event-driven workflow system. So I'm going to talk about Argo Events and what exactly it has to offer. So first question is, what is Argo Events? Well, it's Kubernetes native event-driven dependency manager. So let's break that definition into parts. It's Kubernetes native because all the components that make up this system or the framework are implemented as custom resources from ground up. It's event-driven. The whole goal behind this project was to react on events. So this framework offers a component called Gateway, which essentially listens to events from external or internal event sources. But that's not enough. Consuming events is one part, but what we really need here is a dependency manager that can manage these different events. So that's where sensors come into picture. So sensors are essentially components that manage these event dependencies for you. So to summarize quickly, the gateways, they listen to events from external event sources, transform these events, make them into cloud event specification compliant, and forwards them to sensors. Sensors, on the other hand, they maintain list of events that they expect from one or more gateways. And upon receiving those events, they trigger a set of actions. Now at BlackRock, in most of our use cases, we have Argo workflows as the triggers. But you can essentially trigger any Kubernetes resource. It can be a standard Kubernetes resource like pod or deployment, or it can be any custom resource. So you can have these things as the triggers. So yeah, we are going to see Argo Events in action. So I'm going to explain what we are going to do here. We will set up a simple image processing pipeline, and we will set up a gateway for S3. And we will have some sensors and some triggers running. Matt? So the first thing is, we don't have Argo Events set up in our cluster, so we are going to set up Argo Events from scratch. So it installs a couple of CRDs, mainly for gateway and sensor, and installs the controllers.
Are you mean to show the screen?
Oops, it's not showing there. All right. Okay, so we just installed a couple of CRDs and the controllers. And we are using S3 to store our input and output image. So what we are going to do is we are going to like put an image on S3 bucket, and as soon as we put that on S3, the system is going to trigger an Argo workflow, and we are going to convert the image into grayscale and put it back onto S3. And that will again trigger another workflow. It will print a simple message saying that the event pipeline is complete. So the next thing is to spin up a gateway. So here is a S3 gateway. It's a spec. It's very straightforward. It has a couple of things like the deploy spec, which is essentially your pod spec, and then it has a type. I'll go into details for what exactly type is, but for now it's a HTTP gateway, and there are a couple of watchers. So watchers are nothing but the sensors. So you can list different sensors in the gateway spec so that whenever a gateway consumes an event from an external event source, it will forward that event to these sensors. So the gateway pod is up and running. So next thing is to configure this gateway with different event sources. Now the event source in this case is input bucket and the output bucket that's stored on the S3. So this is how the event source looks like. It's pretty simple. We are just mentioning that we are interested in listening SNS notifications from input and output buckets, and we should get the event only when there is an object put. And the event sources are configured using Kubernetes config map. So that way you can essentially add or remove any event source you want on fly. You don't have any downtime for gateway. Gateway can continue to keep on running, and you can essentially add the event source anytime. Okay, so the next thing is to set up the sensors. So we will have a couple of sensors. The first one will be the input sensor, and the second will be the output sensor. The sensor spec is also pretty much straightforward. It has a signal, which is basically it's specifying from which gateway this sensor should get an event. The gateway name is S3, and from which exact particular event source. The event source is input. So as soon as this sensor receives an event from S3 gateway and event source called input, it will trigger an Argo workflow. So in the source, you will see that there is a Argo workflow that's described. It's the inline Argo workflow. This example has inline Argo workflow, but you can basically store your workflows on S3 buckets. You can store it on Git, and you can reference those workflows in the spec. I guess sensor pod is up. We need to create one more sensor for the output bucket. Okay, so the setup is done. We have our gateways and sensors ready. So the next thing is to upload an image to S3 bucket.
So we already pre-prepared an image, and we're just going to, as you said, load it, but also important to watch the right side of the screen to automatically see the workflows and pods being created.
This one, no. Yeah, we just need to transfer an image.
Did you save it? Give us a second here.
Give us a second, guys, yeah.
There we go.
Okay.
Cool. Okay. GCP.
And we have our cluster set up on the Google Cloud right now for the demo. So, and we have an S3 Minio server running there. It's a single instance Minio server. Okay, so on the right side, you can see there are a couple of workflows that got triggered. The first one was the workflow that actually converted the input image into grayscale. It put it back onto S3, and that triggered another workflow, and that just simply printed like a message saying the pipeline is complete. So we are going to download the grayscale image from output bucket. Right.
So there's our output image.
There is our output image. So yeah, so this is this is how simple it is to use Argo Events and to like chain your events basically.
That was our original.
That was our original image, yeah. So basically you can have multiple gateways and sensors, and you can chain these gateways and sensors and have your events flow from end to end and set up the workflow pipeline. So next thing is, so next thing is I want to go over a couple of features that this framework has to offer. So the important one is it's a lightweight. So you saw that we just needed a couple of CRDs to get started with Argo Events. And also we package everything using containers. So depending upon the implementation of your gateway, your container sizes can be as small as few megabytes. So it's very lightweight framework and very much focused on eventing. It's easily extensible. So when we started writing this project, we chose Go as our programming language, but we don't expect users of this framework to write their code in Go to implement a custom gateway. So the gateway is divided into components such that each component can talk to other component over Go channels, HTTP or gRPC. So as long as your implementation can, or your programming language supports HTTP or gRPC, you can essentially write a custom gateway. And it is configurable at runtime. So you can add or remove event source anytime you wish. There is no downtime for the gateway. So let's talk about a couple of use cases that we have at BlackRock. So BlackRock, as being a financial firm, we run a lot of financial models. We generate many reports for our portfolios, for our funds, but some of these processes, they need data from some third-party financial vendors. And so we use this platform called data sourcing platform, which essentially acquires financial data from different vendors, validate that data, process it, and then feed it to downstream applications. Now the constraint on this system is we expect data feeds from vendors to be present at a certain time in a day. So we use a gateway called File Watcher Gateway whenever there is a new data feed available from vendor. So the File Watcher Gateway generates an event whenever there is a new vendor file. And to make sure that these vendor files arrive at a certain time in a day, we use Calendar Gateway. So once we get these files in BlackRock, we trigger some ETL workflows, which transforms these data feeds into an internal representation and store it on S3. And once we have this data on S3, basically we consume the SNS notification using S3 gateway, and then we trigger the Spark jobs. I won't go into detail what these Spark jobs do, but they help generate financial models. Now, we got the data from our vendors. Now, the next thing is to make sure that we make that data available to our internal financial analysts and researchers. So that's where our data science platform comes into picture. The data science platform offers a variety of Jupyter notebooks that a user can spin up on the fly and run their research workflows. One of such Jupyter notebooks is Fixed Income Notebook. So this Fixed Income Notebook basically helps deliver different teams, generate alpha, which is market-leading performance for different portfolios to their clients. Now it has some it has some complex algorithms like risk scaling, transformation, and it runs optimization on the final financial model. So it has pretty complex mathematical computation, and this whole process takes time. So users of this notebook, although they can run this notebook on fly, they don't want it. They want this particular notebook to run on a specific business date using a very specific financial calendar and only when market closes. So for all these requirements, we use Calendar Gateway and we configure these schedules, but that's not enough because we need to make sure that we follow certain SLAs. So we also configure these gateways with some offsets. So that take care of the failure scenarios. And once the schedule completes, we use Argo workflows to deploy these Jupyter notebooks. And these use cases are just like tip of iceberg, because at the end of the day, we still have something like this at BlackRock. We have so many different teams trying to coordinate with each other, run their workflows. But what the sensors and gateways provide us is this clear sense of responsibility of consuming events and then triggering different actions. So Argo Events as whole provides a nice interface so that different teams can coordinate with each other and run their workflows.
So I just want to kind of conclude with some takeaways and some learnings from this project. So one of the most important and apparent external insights that we took away was this growing industry trend towards automation, especially on the cloud and especially on Kubernetes. So even in the last year, we've seen a number of new projects tackling similar solutions, but focused on different use cases pop up in the ecosystem. We mentioned the projects earlier in the presentation, things like Airflow and Brigade, and also new platforms even coming up here and being at KubeCon and hearing some of those as well. So another interesting area that we were watching was the Kubernetes API space. And so since the adoption of the Kubernetes custom resources, since they were released in 1.7, going with a project like Argo and building upon that with custom resources really confirmed our decision to choose Argo as the workflow solution. And I really believe a simpler unifying eventing platform using custom resources built upon Kubernetes is a way forward for us. And personally, I think I speak for both of us. Like a year ago, I didn't know anything about Kubernetes, and now we're here presenting to you guys. So simply having the opportunity to work on an externally open source project has been a really awesome experience. And we came to appreciate the real fast-paced nature of development in the open source community, and being able to quickly adapt to the ever-shifting landscape. So internally, Argo Events has already kind of exceeded its initial scope. As Vaibhav showed you guys, we're using it for the data science platform, but we're also exploring it for other solutions. As I hinted to before, we have a heavy batch-oriented process at BlackRock, and automating this today on our monolithic kind of legacy system, using something distributed and on Kubernetes and containerized is a very attractive solution for us. So we're currently evaluating using it as an operational tool, integrating it with the rest of the Argo projects, including the Argo CD project. As a DevOps kind of full suite solution. And lastly, personally, I think we've gotten tons of exposure to working on this project and collaborating with companies across the United States, and learning really new and exciting things. So we're really excited to share the story and share the project that we built. We really want to continue to develop new tools for the future of Kubernetes-based automation. And we urge anyone interested to, don't hesitate, reach out to us. We'll be here after. Check out the Argo project online. And big shout out to the Argo folks for being very receptive, for kind of welcoming us into the community along the way. So yeah, thank you very much. And we'll now open it up for questions.
Yep.
Can you go back to the gateways and show what's available now, and maybe explain a little bit about what goes into creating a custom gateway?
Something like that, like this?
Yeah. So I thought there was another slide you had that showed like 5 or 6 different available gateways now.
Oh, sure. Yeah. So this one, right? Okay, so we out of box provide like some core gateways for webhooks, S3, SNS notifications like calendar gateways, even messaging queues like Kafka nats, and even you can have Kubernetes resource as an event source. So any updates to any Kubernetes resource, standard or custom, you can watch those events basically. So these are like provided out of box, but then you can write your own implementation of a gateway, and that implementation, you can write it in any language, basically. And you don't have to worry about like different components of like handling what happens when a new event source gets added or removed. You don't have to worry about that. All you need to provide, the implementation is just what event source you try to listen to and how you want to consume that event. That's it. It's about, yeah, exactly. And if you want to write in Go, then we already have the core gateways in Go, so you can just like literally have that template and copy it to for your gateway and just change that particular piece of code that consumes events. Yeah.
These gateways are part of Argo project, or are they part of? So let's say that I wanted to write one for S3 Azure Blob Storage. So would I contribute to your repo, or do we?
That's a great question. You would contribute to the Argo Events repo. The Argo project, the workflows are kind of agnostic to the events happening, right? We're just trying to trigger. To repeat the question, was if we were going to build a custom gateway, say for Azure blob storage, which repo would I contribute to? Which? So it would be the Argo Events repo. The Argo Events kind of integrates the implementations of each of the event sources. You can implement an interface, open an issue, and we'll take a look at building it.
Well, I can one other question on this: how do you guys handle like long-running transactions or long-running workflows? Do you have an example of something that might run for days, maybe the law wasn't, but just long-running stuff? How does that handle?
So as far as like the Argo workflows, so as it triggers, we run Argo workflows, right? So the sensors and gateways are continuously like long running. Sorry. So the question is, how do we maintain like long running processes? Like how we maintain like long running workflows, or how we even monitor them, right? So yeah, sensors, gateways are continuously long running, but the workflows, so Argo team provides an UI that you can like monitor your workflows, but it's not exactly part of Argo Events. So as Argo Events, I don't want to say we don't care, but whatever trigger that you execute is because we don't maintain that particular piece of software. You can either trigger a workflow, Argo workflow, or any Kubernetes resource. So it's like yes. Yes.
And because they're just resources on Kubernetes, right? They follow the same paradigm between controller, and object,
Yep.
right? An API object. So speaking for the Argo workflows, right? You create a workflow. The Kubernetes system will ensure that your desired state matches your actual state matches your desired state. So
The workflows get created as Kubernetes native objects.
Right.
yes, that's correct. To clarify, the Argo workflows are Kubernetes native objects that you can use kubectl. Any other questions? All right. Well, thank you very much.
Thanks.